Hello everyone. So I have started a new series of mathematics. Here I will cover those all important chapters of mathematics and these all unit from where the most of the marks are being asked from. Most of the questions are being asked from those chapters. So here we can understand first the concept. What is the concept of that? So this is that unit one. It is called real number. In real number, it contains 6 marks questions from here. So you need to be more aware and confident from here. And after completing these all things, we can do further more chapters, and thus we can be able to complete everything properly. And after completing these all unit properly, and then we can discuss with previous year question paper and with its solution, and then there are 5 sample paper which is very important here, and I am covering these all things from Sivdas sample paper. It's very important. It's very you can say that there most of the questions are being raised from this sample paper, and it's being studied by the many students who is covering from here, so they are always getting benefits from here. So it's good, you can complete from here those all points, and after that we can be able to discuss with those all sample paper with its explanation. So let's start with first chapter. It's real number. So let's start from here. It's real number. Let's recall R equal to real numbers. All rational and irrational numbers are called real numbers. All integers can be expressed as rationals. For example, 5 equal to 5 by 1. So if there is not denominator means that 1, you know very well. But you can revise from here. We are starting from beginning. So it will be very easy for you to understand. And these all content are really very important for you. And so I will again tell you to keep revision properly and understand everything. So now let's start from here. So I equal to integers. So all numbers from it's starting with -3, -2, -1, 0, 1, 2, 3 are called integers. And next, roots of the prime, like that under root 2, under root 3, under root 3 x star, these are irrational. So now we can come here with rational and irrational. So it's rational numbers, the real numbers of the form p by q. So q equal to not 0, and p, q, I are rational number. These all are rational number, and you can see here that irrational numbers we have already completed from here. So one more thing is given here. You can understand from here. Yes, these all things. These irrational numbers, so real numbers which cannot be expressed in the form p by q, and whose decimal expansions are non terminating and non recurring. So you can complete these irrational numbers, how it is happening here. So alert, what is alert? Decimal expansion of rational numbers is terminating or non-terminating recurring. So you can understand from here. Now next is natural numbers. Counting numbers are called natural numbers. So natural numbers 1, 2, 3, 4, 5, 6, 7, 8. Just like counting numbers are called natural numbers. Then W equal to whole numbers. So 0 along with the natural numbers are together called whole numbers. That's why we are starting with 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then continue. We can keeping it. So it is called whole numbers. And to see, we can remember from these all things. Remember this: all natural numbers are whole numbers. So all natural numbers are whole numbers. It's happened. All whole numbers are integers. So all whole numbers are also integers. All integers are rational numbers. So all integers are rational number, and all rational numbers are real numbers. So these are all rational numbers are real number. So now next come here, we can complete even numbers. So we know very well even number and odd numbers. So even numbers, that natural numbers of the form 2n are called even numbers. It is starting from 2, 6, 8, just like that. Even numbers, even and odd, you have seen that 1, 3, it's starting with the odd number, and even 2, 4, 6, 8, like that it will be continue. And when we are talking about odd numbers, so it is called natural numbers of the form 2n minus 1 are called odd numbers. So it's just like that. If we are talking 2n minus 1, so it is called odd numbers. So odd number is starting with 1, 3, 5, 7, just like that it will be continue. We can uh, count it as a odd numbers. So now we can complete from here prime numbers. So prime numbers, the natural numbers greater than 1 which are divisible by 1 and the number itself are called prime numbers. So prime numbers have two factors, for example 1 and the number itself. For example 2, 3, 5, 7 and 11 etc. So prime factor have what? Prime factor have two factors, so 1 and number itself. So either that number will be divisible for that one and particular one, and after that particular with that number. So these are the numbers 2, 3, 5, 7, 11, 13 etc, just like that. These are all called prime numbers. So 1 is not a prime number as it has only one factor. So 1 is not a prime number, so you need to be aware from here. Next is composite numbers. The natural numbers which are divisible by 1 itself and any other number or numbers are called composite numbers. For example, 2, 6, 8, 9, 10, 12, 14, 16 means that numbers are also means composited with divisible by 1 and other numbers also, so it is called composite number. To note, 1 is neither a prime nor a composite number, so you need to be aware from here. So now we can start from here main concepts. So I'm just completing from here. Euclid's division lemma is given two positive integers a and b. There exists unique integers q and r satisfying bq plus r. So 0 is you can see here greater than minus than r and greater b. It's given then. So it's r b is greater than r, you can see here. So notice this each r is less than b, each q and r is unique here. Now next is, what does this mean? So if it's given that a b q r, so a means that 18, b means that 2 multiplied by n plus r, and these all things are given here. Everything you can understood from here. Now next come with next point. Its application of lemma we have done, and that Euclid's divisions lemma is used to find HCF of two positive integers. Find HCF of 56 and 72 step. So there are two steps of to finding out the HCF of 56 and 72. So first is applying lemma to 56 and 72. So first we are applying from here. So it's just like see how we can do. So we are going to first 72, then multiply by 1 and plus 16, it is coming here, just like 72, and 56 equal to 16 multiplied by 3 and plus 8 equal to comes 56. Here it's being shown. So take a bigger number and locate b and r. Since 16 is not equal to 0, consider 56 as the new dividends and 16 as the new divisor. So again here, again 8 equal to not 0, consider 16 as new dividend and 8 are new divisor. So 16 equal to 8 multiplied by 2 plus 0. It's here given here now. Now next we can complete from here. So since remainder is 0, divisor 8 is HCF. Getting? Although Euclid's division lemma is stated for only positive integers, it can be extended for all integers except 0. For example, b equal to not 0. Getting? So now let's start with now next constructing a factor tree. Now we are constructing a factor tree from here. So you can be able to understand from here. See, uh, steps. So what should be steps? Write the number as a product of and prime number of the composite number. Example is given here. Factorize 48. So how factorizing here? 48, and then it's being with 2, and then you can see rule 1, begin with the smallest prime number. Getting? So again, then starting with here with 2, and rule 2, prime numbers are used always on left hand side factors tree. Getting these all things? Now we have done 2 here, so it's come 12. So 12 with 2. To rule 3, do not move the next prime, it still divides by the same prime numbers. So you do not remove these all primes, still it's being divided by only one prime. So after 2, with when we have completed with 2, then it comes with here 6. So 6 is also with 2 prime factor prime number. So it has come here now 3. You can see here it's 3. So it's being said here that repeat the process till all the primes are obtained. Means that all the primes are obtaining from here. The we must keep repeating here. And prime factorization of 48. Then we can write here prime factorization here just like that. Uh, um, 2 power 2's power of 4 multiplied by 3 means there are 1 2 3 4. So 4 2 has come, so we can write here 2 and there how many are there? Number 4 to we can write on the top, it's 2's power 4 called and multiplied with t. So we have last 3 has come, it has come 3, so we can write here 3. So I'm coming with next point, which is here. Now we can complete clear from here. Fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, and this expression is unique apart from the order in which they appear. Getting? Now next, applications. So applications are given to locate HCF and LCM of 2 or more positive integers. Second, to provide irrationality of numbers. Third one, to determine the nature of the decimal expansion of rational numbers. Next one is given here, that algorithm of locate HCF and LCM of 2 or more positive integers. So we do step 1. So in step 1 we do factorize each of the given positive integers and express them as a product of powers of primes in the ascending order of magnitudes of primes. Next, step 2. So to find HCF, identify a common prime factor and find the least powers and multiply them to get HCF. Getting? Now here step 3. To find LCM, find the greatest exponent and then multiply them to get the LCM. Getting? We have done from here. So now next is we can cover from here these are things. So we have done to multiply with HCF. Now, third step we have done to find the LCM, find the greatest exponents and then multiply them to get the LCM. Getting? Next is that point 2, to provide irrationality of numbers. So what we have to do? Point 1, the sum of difference of a rational number and irrational numbers is irrational. Getting? Second, the product or the quotient of non-zero rational numbers and an irrational number is irrational. Getting? Now third one is given that the determine the nature of the decimal expansion of rational numbers. Let x equal to p by q. So p and q are co-primes. B rational numbers whose decimal expansion determine terminates getting? So its expansion is being terminates from here. Then the prime factorizations of q is of the form 2m and 5n. So m and are known negative integers. Getting? Now let's start from here. Let x equal to p by q be a rational number such that the prime factorization of q is not of the form 2m and 5n. You can see that power of m 2m and power of 5 is equal to n. So m and n being non negative integers, then x has a non-terminating repeating decimal expansion. Its LRT is being given to the power 3 equal to, can be written as equal to 2 the power 3. So you can write here uh, 2's power equal to 3 equal to 5's power here 0. So 5 the power equal to 2 can be written by 5 the power equal to 2, and 5 2, it's 2's power here 0 and 5's power equal to 2. So just like that we have completed this unit 1, where this unit is containing 6 marks in your examination, and these are very easy and interesting questions. So I will come with those all important questions which is really very important and helpful for you. So you can easily get 6 marks from here. So now next chapter is next unit is about algebra. So you know that what is the role of algebra. There are 20 marks, means that 20 marks questions are being asked from this unit. So you should must be aware and confident. We can first complete those all important facts as we have completed from here. These all rules and formulas are really very important for you, and after completing these all things, I will come with those all important questions which is really very important, and then I will come with previous year question paper which is very important to understand the concept of board members, that how they are framing questions, and after completing those we can be able to complete those all important sample set which is very necessary for your examination. So keep revision, be update, and keep your practice in mathematics, and keep revision of other subjects also. And I will see you with my next I'm just coming with my next video, chapter number 2, where we will cover algebra portion, and then we can keep continuing to fulfill everything properly.